Hi there, physics students. Anytime something is moving in a circle, it's accelerating. And I have here a clip of a roller coaster going around a loop. So when the roller coaster reaches around here, all the way to there, it's in a circular path. Here's why that's significant. Anytime something is moving in a circle, then its velocity is changing. So let's draw us a perfect circle, and we have an object here, and it's moving with some speed v, and it's some distance r away from the center. And at some other point, it's still going to be a distance r away from the center, but now its speed has changed. So at all the different points, so look, right about here, its velocity would be like that, and the radius is like that, v. So since the velocity is changing constantly, that must be a form of acceleration. So we call this centripetal acceleration, and it is actually defined by v squared over r, where r is the radius of your circle and v is your speed. So we are kind of assuming that v is constant, the speed. Let's make that the speed. The speed is constant, but the velocity is changing just because the direction is changing. The proof for this expression involves some fairly straightforward calculus and using polar coordinates instead of Cartesian coordinates. So it's not that hard, but I'm not going to do it right now. So you can certainly investigate that if you want. So anytime something is being forced to move in a circle, it's experiencing acceleration not because the speed is changing necessarily, like in the case of the roller coaster. The speed here is probably the same, but the direction is changing. And that weird effect of that angular change is still a form of acceleration. And you're definitely going to feel that in a roller coaster like this. So I hope it's fairly obvious that anytime something is forced to move in a circle, it's going to have this acceleration. And by the way, that's called centripetal, meaning center pointing. So if I kind of make the circle even bigger here, and I think about the top of the roller coaster, and I don't know which direction it was going. Oh yeah, that way. So at the top, its speed is that way, the radius is that way. Well, the acceleration is also that way. It is center pointing. So it is always, and this is because of the angular nature of the change in the speed. It's always pointing towards the middle. So as long as you're moving in the circle, which is the top half of that arc right there, the acceleration is always pointing towards the middle. So here you are at these three different points. There's going to be an acceleration downwards. So gravity is acting downwards too, but if this acceleration is big enough, then you actually feel the acceleration towards the center more than you feel gravity. So this v squared over r, if it overcomes the acceleration due to gravity, then you're actually going to feel a force pointing you towards the middle instead of the force pulling you towards the ground. So centripetal acceleration is anytime something is being forced to move in a circle, it's on a track, it's on a rope, it's in some kind of system where it's being forced to move in a circle, then you automatically have an acceleration that's a little bit different than you're used to having. So it would be v squared over r.